Right, okay, we're live. So, Pal and Daniel, thank you so much for that talk. That really went into depth into the kind of things that you need to think about when you're trying to develop the software. And then the simulation, of course, shows you that sometimes it's good to just have it happening in a pure fashion before you deal with all the noise on a competition day. So, a few questions for you. If I can find the beginning of them, where are they? How do you manage the threads? Is a question, but I think you might have answered that in the talk.
Yeah, or maybe it's a question about how to manage the concurrency coming from sensors and all that kind of stuff, which I wasn't talking about that. I was kind of nicely ignoring all that problem. I was just talking about the high-level stuff as if it was easy.
We were using threads, actually, process in this case, to do those disconnected pieces, like reading sensor, which takes some time, or getting OpenCV image processed, which can take some time in separate processes, and then just feeding results down the chain onto the behavior like place. And then we use MQTT for it.
Yeah. Speaking of MQTT, did you find it was fast enough to cope with autonomous and remote control, or was it not quite fast enough to keep up?
Actually, depends what you're trying to do with this. If you want to do the remote control, where you have only 2 or 3 stages when you read the joystick and then feed it into the overall controller, then lower controller, even lower controller, and you just say start going forward or stop going, that particular little delay, you will notice it. We were running main loop at 20 times a second, so it was all right. I calculated roughly 150 milliseconds of latency being introduced by MQTT. And it was all right for reading sensors at 20 times a second and then feeding just final result as a small byte into it. Reading or sending things to motors, that was okay. But then sending the whole OpenCV images into second stage of processing, it was a bit kind of on the edge. But the moment we tried to send logging details, telemetry, then it kind of clogged it completely. So it is for some things, not for some other things. Richard Gemmell made a little test afterwards as well and found out what is all right to be used for, what isn't. And there, for a couple of stages, it's okay. But if you need to have 100 times a second something processed to be the 5-6 stages, that would be too much. But small messages, that's fine.
So William Harvey, I think you answered this in the chat, but just for the record sort of thing. William was saying that he'd love to investigate coroutines and states a bit more. Where would you suggest he starts?
Yeah, so I found some really, really good talks from David Beasley. You can look it up on YouTube, and I put a link on the chat as well. So you can see the slides and the talks. They're really, really good about concurrency and other techniques and coroutines in detail, really.
Okay. Next question. This was one from me because I suddenly had images of artificial intelligence for a minute. With everything feeding into everything else at different times, and you've got loops here, loops there, do you ever get emergent behavior, or does it just behave like you think it ought to?
I guess we'll see. Yeah, that's the idea. So that was part of the some of the inspiration. It's called the Subsumption Architecture, which goes back to the 80s, I think. And the idea is that it's really based on observing the behavior of simple animals like insects, because they don't have this kind of intelligent or really clever kind of processing power, but they have really, really impressive behavior. And it's all based on mixing these simple behaviors together, and somehow you get some sort of emerging complexity. That's the promise. But I guess the criticism is that it's really hard to manage once you reach a level of complexity and you have all these competing behaviors all over the place, and you really need to be careful to make sure it actually works. So yeah, I'm not sure about that yet. I'm not at that stage yet.
I would like to add something else, which is just before these new behaviors emerge, just by seeing those behaviors being executed one after another, gives you one of those chills looking in the rover and said, it is doing its own thing.
Exactly.
I'm scared of.
Yeah.
I think this might be our last question, actually, but unless anybody else has any more, just post them into the stage. do you have a method to totally override any movement in case of a crash or unwanted movement? Do you have a panic button?
In simulation, yes. I'll need to try it for real, but it should work. It's actually pretty easy because you just need to stop the motors or anything, any movement. So the idea is that adding something like that is pretty simple without having to modify the other parts of the system.
And we did it by exactly what Paul said. In the lowest level, at the motor level, motor controller, we had a kind of a backdoor where it would feed directly off for GPIO or for another MQTT message. And if it receives that one, it would just kind of switch off all the motors and stop doing anything, just in case.
Do you find you've got the software side, the simulation side? Do you find yourself more and more thinking, I really ought to simulate that before I do it for real?
Definitely.
Do you put the simulation ahead of that of development now?
Yeah. Yes. One of the reasons was it is much easier to think of the software. We started from hardware perspective. It was really new, interesting stuff to do. But if you want to do something serious, this tedious long loop takes it much harder to develop the software for it. But then you put in a simulation, then you stop tinkering with running behind after the rover to pick it up, switch it off, put it back to first place, and start it again. But in simulation, you just kind of press stop button, play button again, and try again.
Yeah, initially spending a lot of time working on simulation and playing with graphics and Pygame and everything felt like a distraction or just an excuse for not doing the real thing. But it actually paid off. So I think it's worth investing time in that, definitely.
When you're dealing with your simulation, how close do you find that the simulation is to the real world results?
So far, what I've tried, it was very close. All the messiness of the world, later on, I tried to iron out inside of the reading of sensors rather than changing the behavior, if possible. So it was really helpful to make this first main implementation of the code. Later on, it was less important, so to speak. At least that was our experience. Yeah.
Okay, I think that might be our last question. Has anybody else got any other questions they'd like to ask? Just pause just to see.
While we're waiting, I just want to say thank you for organizing this event again. We really were overdue for one. So hopefully next year we all get together in Cambridge again.
Yeah, thank you very much.
Hopefully so. Well, I just want to say thank you for doing a really interesting talk, and also thank you for taking the time to do the Q&As. Really appreciate it.
Thank you for having us.
And I bid you both farewell.
Okay.
Thanks both.
Bye.
So that was Pal and Daniel on software and simulation. So our next talk is about PyWars Turkey. Now, it's really interesting because PyWars Turkey came out of our competition, and they came and competed, and then they've taken it back to Turkey and held their own. It's really interesting to see how they've done it differently. So that's really exciting to look forward to. We've actually got according to my schedule, we have a tea break at 2:30, which is lovely because I could do with a cup of tea. And then we'll be back at 2:45 for PyWars Turkey. Also at 2:30, and as I say, if you miss anything, it will be on YouTube later, hopefully with the Q&As and stuff. Lovely editing job. Also at 2:30 over in the sessions area, we have Dr. Footleg, Paul Fretwell, talking about designing your own robotics electronics, circuit and PC design for Pi add-ons. Now, I know we held a poll yesterday and partly today about who would want to design their own electronics. About half of you said you would, and half of you said you already had. So that may be of interest, or just stay with us over here for the PyWars Turkey talk. That came out wrong. So we have that. Then after there's another short break after the PyWars Turkey talk, just to give us a bit of a breathing space. Then we have lightning talks at 3:30 in the stage, And in the sessions area, we have Rishan Sharma talking about AI and machine learning, which was postponed from yesterday because of technical difficulties, but we have tested it today. So I will see you all back here at 2:45 for the Pi Wars Turkey Talk, or enjoy the session. See you shortly.